Hello students, following question is from part test 2 subject signals and system chapter Z transform, and the question is asked for 1 mark. The question is a sequence x of n with the Z transform, that is x of z is equal to z cube plus 2z square minus 3z plus z inverse minus 4z raised to minus 3 is applied as an input to a linear time invariant system with the impulse response as h of n is equal to 2 times delta of n minus 2, where delta of n is equal to 1 for n equal to 0 and it is 0 otherwise, and we are supposed to compute the output at n equal to 2. So we are given that x of z is equal to z cube plus 2z square minus 3z plus z inverse minus 4z raised to minus 3, and h of n is equal to 2 times delta of n minus 2, where delta of n is equal to 1 for n equal to 0 and it is equal to 0 otherwise. Fine. So first what we'll do is we will compute h of z. So what we get is 2 times z raised to minus 2. Fine. So this is using direct simply formula for delta of n minus k we have z raised to minus k. So here it is n minus 2. So we have z raised to minus 2. Now we know that y of n is equal to, that is always output is equal to convolution of input with the impulse response. So in Z transform, y of z would be equal to x of z times h of z. So we have, if we substitute the value of x of z and h of z, we would have this equation. Now solving this equation, we would get the value of y of z to be equal to 2 times z plus 4 minus 6 z inverse plus 2 times z raised to minus 3 plus minus 8 z raised to minus 5. In the next step, we would compute the inverse z transform, that is we would get y of n to be equal to 2 times delta of n plus 1 plus 4 times delta of n minus 6 times delta of n minus 1 plus 2 times delta of n minus 3 minus 8 times delta of n minus 5. Since there is no term of delta of n minus 2 in this equation, the output at n equal to 2 is 0. So in our case, the final answer over here is 0. So whenever we are given such kind of question, what we will do is simply find the value of output in the Z transform, then come back to the time domain and find the final value, which in our case is 0. Thank you.